Welcome to everyone. Myself, Dr. M. Mohana Keerthi, working as an assistant professor agronomy, School of Agriculture, Research, University, Varangal. Today, I'm going to deliver about atmospheric Earth and what are its composition and how much the heights extend the atmosphere and the structure of atmosphere. In this, all we are going to discuss in the part one. In part two, we are going to discuss about what are the different atmospheric variables there and based on the height the atmospheric pressure how it is varying, that is we are going to discuss in the part 2. So this all topics is covering under the title of introduction agrometeorology and climate change. First, here we are going to discuss about sphere of earth globe, means spheres of the earth globe. Already we know the earth is which shape, means elliptical shape. Here there are four spheres are there. One is hydrosphere. Hydrosphere is nothing but where the water and ice caps are present. That area is called as a hydrosphere. Particularly the ice caps are present, that area is called as a cryosphere. And the second sphere is called as a geosphere. Geosphere is nothing but it is a solid land and rock. Where the rock and solid portions land is there, that area is called as a geosphere. In this, where particularly rocks are present, that area is called as a lithosphere. And the third, foremost important is atmosphere. Atmosphere is nothing but where the gaseous portions are present, that area is called as a atmosphere. And fourth one is biosphere. Biosphere is nothing but where the living organisms are present. That area is called as a biosphere. So in this four sphere, today we are going to discuss about atmosphere, composition, structures, how the atmospheric pressure is varying, what are the weather variables are there. This in detail we are going to discuss. So it's the, you see, this is the elliptical space of the spheres of the earth. Okay, what are the spheres of the Earth globe? I already told this. You see here, geosphere, Earth portion, where the gaseous portions are there. Now, this is atmospheric pressure. Here, rocks are there now. So this area is lithosphere. Water is there now, hydrosphere. This is ice crystals are there now, cryosphere. Okay, first we are going to in detail we are going to discuss about atmosphere. Before going to the discuss about this different composition, first we need to know about what is meant by atmosphere and what are the uses. Okay, atmosphere is nothing but gaseous envelope covering in the earth extending upward direction. So gaseous portion covering in the earth and it will be extending upward from the surface. Atmos is nothing but Greek word. It is a Greek word, nothing but vapor. Sphere is nothing but it is also a Greek word sphere. So this atmosphere, the word is derived from which word means a Greek word. Okay. What is the nature, characteristic of the atmosphere? Means atmosphere is complex system. It is a colorless. It is a odorless. It is a tasteless and physical mixture of different gases. And atmosphere, the air is the mobile. It is not a static. Means not static and it can compressible and it is a expandable. This is the characteristics of the atmosphere. One is complex system, colorless, odorless, tasteless, physical mixture of the gases and mobile and non-static. It is a compressible and expandable. It is a dynamic. How means it is influencing the due to the atmosphere. It is influencing the physical, chemical and biological activities of the earth. So whatever the biological activities occurring, chemical activities, physical activities, everything based on the presence of the gas. Okay. In case it is imagine there is no atmosphere means no life. Okay. What will happen if no atmosphere means the daytime temperature will reach up to 95 degrees Celsius. In case same there is no atmosphere means the nighttime temperature will reach up to 1 minus 145 degrees Celsius. Okay, what is the density? Total mass of the atmosphere mass means 56 into 10 to the power of 4 tons. And another important concept is called as aerosol. Aerosol is nothing but the combination of solid and liquid particle, combination of solid and liquid portions, it is called as a aerosol. Okay, what all the solid portions are there? Dust, salt, smoke, fungal, and bacteria, pollen. These are all the solid portions. And now, first we are going to discuss what are the uses of atmosphere. Okay. Here, the atmosphere providing the oxygen. Oxygen uses this respiration for all living organisms. And the second gas is carbon dioxide. Carbon dioxide is useful for the photosynthesis. So, in presence of the carbon dioxide, without this temperature, it will reach the minus 23 degree. In case when the temperature is increasing, because of temperature increasing, it hold the carbon dioxide. In case the carbon dioxide level is decreasing, means the temperature will goes down minus 23 degrees Celsius. And third gas is nitrogen. So presence of the nitrogen gas only, the plant growth is the, it means you know that essential element, means essential gas is nitrogen, also one of the important. It is dilute the carbon dioxide, means oxygen, and regulate the oxidation and combustion process. Okay. And the fourth use, it is atmosphere is the one of the medium for transportation of pollen grains, and it is protecting the all living organisms and crop plants from the harmful ultraviolet rays, and it providing the rain, because of the atmosphere only rain is providing. It is given the source for water vapor and cloud, and it is presence of the atmosphere only weather is moderating and protective all the wall against, it is a protective atmosphere called is a protective wall against the bombardment of the meteors. Okay, next one is what are the composition of the air. So in atmosphere, so in a it is a mechanical mixture of gases and liquid and solid portion. Gases will be present, liquid will be present, and solid portion. Okay, here what are the constituents are there, means there are three. One is nearly constant constituents, trace constituents, highly variable constituents. What are the means? Nearly constant constituents, trace constituents, and highly variable constituent. Okay, first we are going to discuss nearly constant constituents. What are the things? Wherever entire globe, this will be constant, permanent factor. Nitrogen gas, how much percentage means 78.08 percentage by volume basis. Oxygen, 20.95 percentage by volume basis. Nitrogen is 78 percentage, 78.08 percentage. Oxygen is 20.95 percentage by volume basis. Next, argon is 0.93 percentage by volume, and carbon dioxide 0.033 percentage by volume basis. And these are all the nearly constant gases. What are the trace minor gases? Neon, helium, hydrogen, krypton, xenon, methane, nitrogen oxide, and radon. Highly variable means it will be place to place, time to time, season to season, it will vary. What all things? Water vapor, nitrogen dioxide, carbon monoxide, and other particles. Okay. Next gas is called as a noble gases. What are the gases? It is a chemically inactive. It is not a active under chemically. It is chemically inactive. So what are the gases? Helium, neon, argon, krypton, xenon, and radioactive radon. Okay. What are the non-variable components? Permanent constituents. So permanent constituents means nitrogen, oxygen, argon, carbon dioxide. These are all the permanent constants. So you see almost 12 gases are there. It is comes under permanent constant. Wherever the entire globe, this is the percentage will be same. And variable components. Variable components nothing but place to place, time to time, season to season it will vary. What are these? One is water vapor, ozone, sulfur dioxide, nitrogen dioxide, ammonia, carbon monoxide, salt level, soil, and water in the liquid or solid. This all will be varied season to season, time to time, place to place. That's why it is called as a variable components. And now we are moving for stratification or layer of atmosphere. Okay. First, what are the layers will be there, means before that we need to know about what is the layer of atmosphere. In that atmosphere held around the planet by the force of the gravity. This we have to know first. How the atmosphere is present in the planet means because of the force of gravity. it can be divided into this series of concentric layer from sea level to up to 64,000 kilometer. So we can divide the atmosphere from sea level to up to 64,000 kilometer. We can divide the different concentric layer. At range of 9,660 kilometer, the molecule with sufficient velocity means it can escape from the gravitational attraction of the earth. Same. Another important thing is in atmosphere, the pressure and air temperature changes with the height. When the height is changing, definitely the pressure and atmospheric temperature will be changed. Changes in temperature used to divide the atmospheric layers. So how the layers are dividing means based on the changes in the temperature. And not only changing in the temperature based on this composition, based on the vertical temperature difference and the chemical reaction and ionization process, we are dividing the different layers. And you know that the atmosphere, because of the atmosphere only, it is act as a road map up to the space. Okay. What are the different layers or stratification of the atmosphere? Based on the vertical temperature, we are dividing the layers. First one is troposphere, stratosphere, mesosphere, thermosphere, exosphere. So lowest sphere is troposphere. Second foremost important sphere is stratosphere. Third foremost important sphere is mesosphere. And fourth one is thermosphere. And fifth one is exosphere. And based on the composition, troposphere and stratosphere, mesosphere having the homogeneous nature. That is why it is called as a homosphere. Combination of troposphere, stratosphere and mesosphere is called as a homosphere. And composition of thermosphere and exosphere is called as a heterosphere. And the chemical reactions will occur in the mesosphere and thermosphere. This combination is comes under hemisphere. And in the thermosphere, ionization process will occur. That's why based on the ionization, this sphere is called as a ionosphere. So based on the temperature, we are dividing 5 layers: troposphere, stratosphere, mesosphere, thermosphere, exosphere. Based on the composition, we are dividing 2 sphere. One is homosphere and heterosphere. Based on the chemical reaction, we are dividing 1 sphere, chemosphere. Based on the ionization, 1 sphere is called as a ionosphere. So now we are going to discuss in detail about this all the spheres in this part 1. Okay. First, we are going to discuss about troposphere, followed by strato, meso, thermo, and exosphere. This all spheres dividing based on the vertical temperature variation. Based on the vertical temperature variation, we are dividing troposphere, stratosphere, mesosphere, thermosphere, and exosphere. So this one by one we will see in the picture. First one is troposphere. Troposphere is considered, it is the lowest sphere. What is the thickness means? 80 to 18 kilometer. The thickness of the troposphere means 8 to 18 kilometer. From the equator to 18 kilometer. From the polar region to 7 to 8 kilometer. So almost 8 to 18 kilometer area is comes under troposphere. On an average, up to 14 kilometer is called as a troposphere region. Height will be changed. This is another very important point. The troposphere is not a static, it is a unstable one. That's why the height of the troposphere is not uniform. Place to place, season to season will change. And the word tropo is nothing but mixing or turbulence. Sphere is region. The mixing region or turbulence region. More mixture of gases or continuously troubles will be there. Air troubles will be there. All weather activities takes place in these regions only. Okay, troposphere means where the air is turns over. The air is turns over means that region is called as a troposphere region. Marked by the turbulence and eddies called as a convection region. Here the layer in this region, the air is the unstable. It is air constantly moving. That's why the aircraft have a very bumpy ride will be there. To avoid this aircraft will move on the above the troposphere region. Almost it is play in the stratosphere region because in stratosphere region there is no turbulence. So in this troposphere region, lower part almost 1.5 to 2 kilometer, that layer is called as a frictional layer. This layer is called as a frictional layer because of here the wind speed will be influenced by the friction will be more. So from the atmosphere surface from the earth surface to 1.5 to 2 kilometer, that layer is called as a friction layer. Same, the wind velocity increases. Carefully listen, the wind velocity increases with the height of and maximum at the top. The wind velocity is increasing with the height and maximum at the top level. The wind velocity is more. That's why in hilly area the wind velocity will be more. You see here in this troposphere, the clouds will be there, more living organisms, hills, all turbulence will be there. When we are moving to stratosphere, it is static region will be there. Okay, what is my planetary boundary layer? The troposphere nearest to the Earth's surface, it is directly affecting the turbulent diffusion. So almost here, how it will be then? It will mix during daytime, stratified at night time with weak or intermediate mix. So how means depth of 100 meter on clear will be there. Calm nights with around 3000 meter or more in the afternoon in the dry region. And another layer is called as a laminar layer. From Earth surface to few millimeter, the air held stationary around solid and liquid surface by molecular forces, which provides the thermal insulation to the body. So you see here, this is a planetary boundary layer. This region is called as a laminar boundary layer. Okay. Next layer is called as a skin layer. In the troposphere region only, the skin layer is there. Few millimeters to up to 1.5 meter is called as a skin layer. The exchange of energy by conduction. Here, the exchange of energy will be there by the process of conduction. Surface characteristic dominates for exchange of the energy. Here, the layer having the direct significance to the plants, animals, and the human beings. So due this environmental continuously changing depending on the different type of soil, types of plants, and variable shading sun side and wind protection methods. Particularly lower part of the atmosphere, around 1.5 to 2 kilometer friction layer, whereas the topography greatly influencing the wind speed. Generally, it will be decrease. Okay. Next on the surface boundary layer, this layer is around 52,000 meter. This friction layer temperature variation will be occur and density variation will occur due to the earth rotation. It is noticeable and wind governed by the surface structure and friction. So micro weather and climatic changes will occur in the friction layer. So all plants, animals, and human beings will be present in this friction layer. And next one is troposphere. So it's a troposphere is the thin layer. It's a thin buffer layer at the top of the troposphere. So between the troposphere and the stratosphere, in dividing layer, this is called as a dividing layer. In between the troposphere and the stratosphere, one buffer layer will be there, dividing layer, that is called as a troposphere. In this region, rising and falling air pockets will be there. This is a translational zone. Height changes according to the latitude. Based on the latitude, that troposphere height will be changed. The temperature will be around 60 to 80 degrees Celsius. Temperature started to increase in this troposphere region. In this, we are going to discuss about some of the important area: lapse rate, adiabatic lapse rate, temperature inversion. This all we will see. What is by lapse rate means? In the troposphere region, decreasing in temperature when increasing altitude. When the height is increasing, temperature is decreasing means that is called as a lapse rate. So this lapse rate otherwise called as a environmental lapse rate. When the rate of decreasing temperature with altitude given time and given location, and also it is not a uniform. So what is the normal lapse rate value means 6.5 degree Celsius. This lapse rate otherwise called as a vertical temperature gradient. So lapse rate having the other names. One is environmental lapse rate, another one is vertical temperature gradient. So what is lapse rate means? In the troposphere region, decreasing in temperature with increasing altitude means that is called as a lapse rate. Okay, what is my adiabatic lapse rate? So here we are dividing important lapse rate is comes under adiabatic lapse rate. In that adiabatic lapse, there are two types of adiabatic lapse rates. One is dry adiabatic lapse rate, another one is saturated or wet adiabatic lapse rate. So here the what is meant by adiabatic lapse rate means it is a thermodynamic transformation without exchanging, carefully listen, without exchanging of the heat between the systems and the environment, it's called as a adiabatic process. If here the air mass is not able to transfer the heat is in adiabatic condition. So adiabatic lapse rate is the rate of changing temperature due to the ascending order air rises and descending order when air falls down of the air masses. Again, this adiabatic lapse rate, we are dividing dry adiabatic lapse rate and the saturated or moist adiabatic lapse rate. Dry adiabatic lapse rate means the rate of temperature decreasing with the height of parcel of dry or unsaturated air rising under the adiabatic condition. So what is by dry adiabatic lapse rate means the rate of temperature decreases with the height of the parcel dry air under the dry and unsaturated air condition. The temperature is decreased means that is called as a dry adiabatic lapse rate. What is the value of the dry adiabatic means 9.8 degrees Celsius per kilometer. When we are talking about saturated adiabatic lapse rate, same, it is exactly opposite of the dry adiabatic lapse rate. Here the temperature is decreases with the height of the under saturated or wet air. So how much temperature will be there means 5 degrees Celsius per kilometer. Okay. Another next important concept is called as a temperature inversion. So what is my lapse rate I told means temperature is decreasing when the altitude is increasing. That is called as a lapse rate. What is my temperature inversion means it is occasionally will occur. That word is very, very important. Occasionally will occur. What it means in some altitude. Occasionally in some altitude. That in the troposphere region. Okay. In troposphere region, occasionally some altitude, the temperature abundantly increases instead of decreases. When altitude is increasing, temperature should decrease. But in troposphere, occasionally in some altitude, temperature is suddenly increasing instead of decreasing. That is called as a temperature inversion. So once again I will tell, this is increasing in temperature instead of decreasing. It is called as a temperature inversion. Okay. Next layer is called as a stratosphere layer. It is a second major layer of the atmosphere. The stratosphere word is derived from Latin. It is called as a stratum. So troposphere is Greek, that stratosphere is Latin word. Stratum means layer. It is exists above the troposphere. After troposphere, the stratosphere is there. I already told in between the troposphere and the stratosphere, one buffer layer is there, dividing layer, that is called as a troposphere. So above the troposphere, the stratosphere layer will start. What is the range? It is thickness extend from 20 kilometer to up to 50 to 55 kilometer. So almost 15% of the total atmosphere masses will be present in the means occupied by the stratosphere regions only. This is called as this region comes under stratosphere region. Okay, here temperature rises. Carefully listen. Temperature rises with increasing altitude. So altitude is increasing. Temperature also will increase. Why means due to the absorption of UV radiation by the ozone layer. Here ozone layer will be start. Ozone layer presence will be start. That's why UV radiation will be absorption will be there. When the altitude is increasing, temperature also will increase because of the absorption of the UV radiation by the ozone layer. Here temperature profiles creates a very stable atmospheric condition because there is no air turbulence. It's a stable will be there. This the atmospheric lacks the air turbulence. I already told you here there is no turbulence. Air density is less. So in the warm at the top of the air density is less. That's why warm at the top, cold at the bottom. So what is the means in stratosphere region? Top region become warm because of the air density is less. Cold down layer, bottom layer having the cold because of the high wind speed. Here completely free of clouds or rarely with the clouds or without rain in restricted region. It's like Antarctica. So cirrus clouds in stratosphere are called as a mother of all and necrosis. Okay, here ozone layer is present, particularly the highest 90 to 23 kilometer up to 30 kilometer significant level will be there. The entire ozone is stratosphere can be composed means it will be third 3 mm thickness layer will be there, and the normal ground layer atmospheric pressure. So same, the ozone layer act as an invisible filter of our planet. It absorb all the harmful UV rays and prevent from the reaching to the Earth's surface. That's why it is a protecting all the life. This upper boundary of this layer. So end of this, the upper boundary of the stratosphere layer is called as a stratosphere. Okay, and the third most important layer is mesosphere. This layer is otherwise called as a ozonosphere because ozone sphere start with the stratosphere, but majority of the ozone layer is present in the mesosphere region. That's why in this region the heat also will be more. So mesosphere is same like troposphere. Here this word also derived from Greek. Meso means middle of the layer. This is the third most layer. This occupies the around 50 kilometer to 80 kilometer from the Earth's surface. It is separated from the stratosphere and by stratosphere and thermosphere by the mesosphere. How? In temperature here, it is this point is very important point. Temperature increasing with height of 5 degrees Celsius each and every kilometer. So once we will reach to the mesosphere means each and every kilometer 5 degrees Celsius will increase. And at the range of 40 to 50 kilometer, the temperature will reach up to 77 degrees Celsius. After that, what will happen means then it falls down low range of temperature, it falls off minus 100 degree Celsius. That's why in top it will be the mesosphere region, the cool layer will be means top of the mesosphere region become cool. So at the top of the mesosphere will be present. Okay, the coldest layer and colder than the Antarctica's lowest temperature in this mesosphere region. And water vapor freezes into the ice clouds. It is a Nautilic clouds, NLC, visible when the sun is from 4 to 16 degree below horizon. It will be Nautilian clouds will be present. And this is another very important. In this mesosphere region only, the chemical activities will occur more. That's why this layer is called as a chemosphere. And ozone also present in this layer. That's why it is called as a ozonosphere. So mesosphere is we can call as a, you see, ozonosphere we call as mesosphere we call as a ozone sphere, and coldest layer and a chemosphere. So there are three names are there. Traces of UV rays will escape from the ozonosphere to help the protection and the vitamins production, kills the harmful bacteria, and it will be helpful for the photosynthesis. The upper boundary layer is called as a mesosphere. And fourth layer is called as a thermosphere, or it is called as a ionosphere. Because of the here ionization process will occur. That's why it is called as a ionosphere. So here literally this sphere is called as a heat sphere. It's a fourth layer. This is a heat sphere. It lies between around 80 kilometer to up to 4,000 kilometer above the Earth's surface. Here, the space shuttles fly in this area, and aurora lights are so found. And particularly, the gases extends in the distinct ionized layers. That's why ionization process will occur. This layer is called as a ionosphere. Here, aurora lights will be present. It will be cations of lights when the sun stick into the gas into the atmosphere above the polar region. So this is comes under aurora lights. Here the temperature increases with the height. When here in this region, the temperature is increasing when the height is increasing. The air density is extremely low. Very little energy is required for the substantial rise in the temperature. So may the temperature is reaches around 1000 degrees Celsius or more. That's the reason here long wave radiations. Radio means long distance radio communications will occur. The short wave radio beams from the ionized cells favor the long distance radio communication also in this layer. So based on this radio communications, this they are again divided into the different layers. Around 6 layers are there. One is D layer. Around 80 to 100 kilometer, that layer reflects the low frequency radio waves. Okay, 80 to 1000 kilometer, that layer is called as a D layer. In this layer, the low frequency radio waves will be reflected. And next one is E layer. It is 100 to 1000, 100 to 130 kilometer. It's nearly heavy side layer, reflects the medium and high frequency waves. Next layer is E layer. It's a periodic E layer around 110 kilometer. It affects the very high frequency. And E2 layer is 150 kilometer. It is a UV photonics activity upon the oxygen molecules. And fifth layer is F1, F2 layer around 150 to 380 kilometer. This application layer, it is important for long distance radio communication. And last layer is G layer around 400 kilometer. In the presence of UV rays, it reacts with the N2 atoms produce the free of electrons. And last layer is exosphere. This is the outermost layer above the ionosphere. It is lies between the around 400 to 1000 kilometer. It is atmosphere. In this exosphere atmosphere only merging into the space. It is a resemble of the rarefied resemble of the nebula. And here the satellite stations are there. And the density of atoms in the atmosphere is extremely very low. And here the hydrogen and helium gases are predominant. That's why mostly here floating will be the hydrogen and because of the presence of hydrogen and helium gases. That's why shuttles are flying in this region. And satellite means stations are also present. Next, in this exosphere region, the temperature is around 5568 degrees Celsius, entirely different from the Earth's surface. At 500 to 6000 kilometers, the density become very low. The coefficient between the natural and particles extremely rare. Beyond this layer, atmosphere escape from the new universe, and this atmosphere merge into the space through this exosphere regions only. And next one is based on the composition, the atmosphere we are dividing two. One is homosphere, another one is heterosphere. Homosphere means including of troposphere, stratosphere and mesosphere, including of tropo, strato and mesosphere, up to height of 88 kilometer. Here why it is homosphere means these three layers almost the compositions are homogeneity in nature. And the second sphere is heterosphere. It is above the 88 kilometer. Composition is not uniform. It is a heterogeneous nature. That's the region. This layer is comes under means exosphere and thermosphere will be there. Here different layers with the different chemical and physical properties will be there. Also referred the thermosphere as a temperature increasing with height. Here the photochemical reactions of UV rays of the solar radiation will be there in the heterosphere region. And based on these spheres of gases, there are four spherical shells of gases around the Earth's surface. Lowermost layer dominated by the nitrogen up to 200 kilometer. Oxygen is dominated up to 1120 kilometer. Average 3520 kilometer, the helium gas is present. Beyond the 3520 kilometer, the hydrogen gas are there. So up to 200 nitrogen gas, up to 1120 kilometer oxygen, up to 3520 kilometer. At the average of 3520 kilometer, helium gas, and beyond the 3520 kilometer, hydrogen gases is more present. You see this picture, you will understand. Lower level nitrogen, followed by oxygen, helium, and hydrogen gases is predominant. Okay, now the part 2 we are moving. We are going to discuss about atmospheric weather variables. What all the weather variables are there in atmosphere and how the atmospheric pressure is varying in different heights. Here we are going to discuss about diurnal and seasonal atmospheric pressure variation also. Okay, why in which layer weather is occurring means troposphere. Why means because of the two reasons. One is presence of air and another main reason is presence of the water. Because of this only all weather variables is occurring in this troposphere region. Okay, now very important part is atmospheric weather variables. Okay, in this region what are the weather variables is there means temperature. First important weather variable is temperature, atmospheric pressure, wind. Fourth one is humidity, precipitation, and cloudiness. So, what are the weather variable means? Temperature, pressure, atmospheric pressure, wind, humidity, precipitation, and cloudiness. Now, we are going to discuss about one by one. What is by temperature? What are the instruments we are using? Are using means what are the instruments are using for measurement of this all weather parameters, and what are the units? First, what is my temperature? Temperature is nothing but is a kinetic energy of molecules. It is the source of the heat content of the Earth atmosphere. So, what is the instrument measurement units you are using? Means which instrument using is thermometer. What is the unit means? Degree Celsius, degree Fahrenheit, and Kelvin. So you see, when the kinetic energy is less, that region is comes under cold. When the more kinetic energy, the warmness will be more. Based on this density, they are dividing cold and warm. And second thing is atmospheric pressure. Atmospheric pressure is nothing but there are different definitions are there. Pressure is nothing but amount of force. Amount of force is applied into a unit area or surface or unit area of the surface. That is called as atmospheric pressure, or otherwise called as a per unit area how much force you are giving. That is called as a pressure, or how much weight of air column is present in per unit area. That is called as a atmospheric pressure. Here, what are the measurement? What the instrument you are using means barometer. It's used for measurement of atmospheric pressure. The unit is MB or inches of mercury. Wind. Wind is nothing but air in motion. It is the amount of pressure change. Is the amount of pressure change. What are the measurement means? Anemometer and wind vane. Anemometer used for measurement of wind speed. Wind vane is used for measurement of wind direction. So air is nothing but wind is nothing but motion of the air or movement of the air. That is called as a wind. Anemometer. So anemometer is nothing but it is an instrument used for measurement of wind speed. This is the anemometer model. Wind vane. This is a wind vane which is used for the measurement of wind direction. So where the arrow mark is showing, where this is the arrow mark, where the arrow points is showing, that is comes from origin. That is indicating that originated area of air means wind comes from area. Next one is humidity. So humidity is nothing but amount of moisture in the content of the atmosphere. How much amount of moisture is present in the atmosphere? That is called as a humidity. So here there are two instruments we are using measurement of humidity. In room level we can use sling hygrometer. In outside we can measure the hygrometer. So unit is percentage. So this is the sling hygrometer. Here inside dry bulb and wet bulb thermometer will be there. Based on this temperature, while rotating this instrument, air will be passed on that. That time it will measure the temperature level. From that we can measure the how much humidity level is there. And next one is another instrument is hygrometer. Here the air will be used for testing the high humidity. Using this instrument we can measure the how much percentage of humidity is there. And next one is precipitation. Precipitation is nothing but it is a supply of water substance from the atmosphere in the form of rain, snow, and hail and precipitation. It is a very discontinuous in space. There are three phases are there in the troposphere. In the precipitation, solid means ice crystal, liquid means water, gaseous means water vapor. Which instrument used for measurement of precipitation means particularly precipitation is nothing but rainfall because of it is a water form. Majority of the water sources we are getting from the rainfall. That's why precipitation otherwise called as a rainfall. Which instrument used for measurement of rainfall means rain gauge. There are two types of rain gauges, automatic rain gauge and manual rain gauge is there. It is used to rainfall we can measure in the unit of inches, centimeter or mm. Next one is cloudiness. The cloudiness is nothing but the factor or the fact of sky being covered with the clouds. So cloudiness means the sky is covered with the clouds. That's it. Or having a lot of clouds. That is called as a cloudiness. This cloudiness is used measurement. Which instrument means leometer. That unit is called as a acta. Okay. How the atmospheric pressure is varying in the different height. You see, the atmospheric pressure definitely varying in the different heights. Pressure decreases with increasing altitude. So that's why when you are moving higher altitude in hilly area, pressure definitely will be decrease. The pressure at any level in the atmosphere may be interpreted as the total weight of the air. So based on the weight of the air, this pressure level will be different. At a higher elevation, there is a fewer air molecules. The air molecules density is very less. Yeah, I will show this picture. You see, in this altitude, higher altitude, if it's a hilly area, in this you see while moving towards the higher altitude, the air density is less. That's why pressure is decreasing. When the air density is less, pressure is increasing. When you are coming to seashore in land area, density is more. That's why pressure is more. So that's why in seashore line, the air density will be more. Due to that, the pressure also more in the seashore line. You see, around 6 kilometer height, the pressure is half the sea level. At the Mount Everest, around 8,848 meter, the pressure is about one third of the mean sea level value. When it is goes to the 4.63 kilometer level, around 15,200 feet, man cannot survive. The lungs cannot absorb the enough amount of oxygen because of the pressure fluctuation. You see this picture here, more pressure is there because of the more density. Here less pressure is there because of the low density. So high pressure. So ground level high pressure will be there. When height is increasing, pressure will be less because of here molecule density is more, here density is less. Density is less in height means automatically pressure also will less. Okay, here the atmospheric pressure is nothing but weight of the air, which lies between the vertically about unit area concentrate centered at the any point. Okay, so if example, particularly in atmospheric pressure, we are talking about isobars. So isobar is nothing but it's imaginary lines drawn on the map wherever the equal amount or same atmospheric pressure is there. So if example one place atmospheric pressure is less, another place also same amount of pressure is there less. So almost wherever the pressure level is same, we are connecting using imaginary limits, that is called as a isobars. Here we are going to discuss about diurnal and seasonal variation. Diurnal variation means it is a day-to-day variations. If example, radiational heating, due to that air will be, when the radiation is heating, air expansion will be there. When the radiation is cooling, the air contraction will be there. Are main reasons for the diurnal variation of the air pressure. Due to the diurnal variation, more predominant near the equator than at the middle latitude. So entirely, the areas closer to sea level recorded the relatively larger amount of variation than the land surface. Okay, particularly equatorial region absorb more heat. When equatorial region absorption more heat will be there because of directly it is near to the sun. So equatorial region it absorb more heat than it losses. Compared to loss of heat, it will absorb more. While polar region it gives the heat more than the very receiving. Means it will be heat release will be more than the absorption. Next, seasonal variation, pressure variation means due to the effect, the annual variation is amount of insolation. Distance of seasonal pressure variation. This variation is are largely in the tropical region than the middle latitude and polar regions. Usually, the high pressure are recorded over the constant during the cold season, over the ocean during the warm season. Okay. Okay, how the pressure systems in the world? How the pressure system in the world? The shape of the earth is not uniform. The shape of the earth is not uniform. It is subjected to uneven distribution of the solar radiation. So you see how the pressure system will be there in the world means the shape of the earth is not uniform. Due to that, uneven distribution of the solar radiation. So shape of the earth is not uniform. Due to that, solar radiation also not uniform. When it is revolves around the sun, the uneven distribution of the solar radiation over the different region. Due to this reason, the solar distribution fall on the solar distribution the surface also is not uniform. So it will be global leads to the contrast in the surface air temperature. This result in variation of the surface atmospheric pressure system, which is known as a standard atmospheric pressure system or standard atmospheric pressure belts. So what are the different pressure belts means? You see, there are 7 pressure systems are there in this earth surface. There are altogether 7 alternating low and high pressure belts are there. Okay, you see, pressure system are belts. So what are the things? First thing is equatorial through low pressure. Equatorial through low pressure, it is between 5 degree north to 5 degrees south. Next one is subtropical high pressure belt. It is called as a northern hemisphere, around 25 degree north to 35 degree north. When the third one is subtropical high pressure belt, southern hemisphere, 25 degree north and 35 degree south. Next one is fourth one is subpolar lower pressure belt. It is around north. It is comes under northern hemisphere, 62 to 60 degree to 70 degree north. Subpolar low pressure belt is southern hemisphere, 60 to 70 degree south. So you see, northern hemisphere and southern hemisphere, high pressure will be there, low pressure will be there. High pressure is in the northern hemisphere is 25 to 35 degree north. Low pressure in the southern hemisphere, northern hemisphere is 60 degree to north 70 degree. Same high pressure will be 25 to 35 in the southern hemisphere is low pressure. It's high pressure. When you are coming comes to the southern hemisphere, low pressure is around 60 to 75 degree south region based on this latitude. And polar high means northern hemisphere, in same polar high in the southern hemisphere also. So totally 7 alternating low and high pressures are there. So this is the polar high here, subpolar low, subtropical high, equatorial low and subtropical high and subpolar low. Okay, what are the different variations are there? Okay, causes of variation. Due to the temperature, hot air expands, it extract the and low pressure. Air will be expand, low pressure, it will be extend, automatically low pressure will be there. But when we are coming to cold air, it will be contract, the pressure will be increased. So that equator region, low pressure is there because of the air will having the more absorption of the solar radiation, it will be expand. Once expand means pressure will decrease. So always remember, in colder region, the pressure will be more because of this high pressure will be there. It will be contraction will be that all cold air will be contract means pressure will be more. When we are coming to equatorial region, the warmness will be more. Continuous heat absorption will be more. I already told absorption will be more than the reflection. Absorption will be more. So due to the more absorption of the heat, the air will be expanded. Once the air is expanded, means pressure will be decreased. That's why low pressure we will feel in the equatorial region. High pressure we will feel in the polar region, particularly colder region. And next one is altitude. At sea level, the air column and exerts fully pressure. But when we stand on hill, okay, sea level, the air column and exert in full pressure will be there. When you are standing in sea level areas, you will feel more high pressure. When we are standing on hills, density of the air will be low and attached with the surface layer also low. Due to that, low pressure we will feel in the higher altitude. Okay, if you are talking about water vapor, the water vapor also one of the important role in the constant the lighter in the colder area than in air which is dry within the result. The moist air of the high temperature exerts the less pressure and when compared to the low air, compared to the cold air. If rotation of the earth, on account rotation of the earth, the pressure level 60 to 70 degree north and south become low. I already told now 60 to 70 degree north and southern hemisphere, northern hemisphere and southern hemisphere, around 60 to 70 degree latitude. That according to the rotation of the earth, the pressure will be low. The rotation of the earth near subpolar belts around 30 to 35 degree north hemisphere and 30 to 35 degree south hemisphere, due to the subpolar region, the pressure will be more. This latitude absorb the air from subpolar belts, making their pressure is high. Okay. Based on the G.D. Coriolis in the year of 1844, he is the French mathematician, indicate that air is deflected towards right in the northern hemisphere. So air is always based on the Coriolis, air will be deflects towards the right direction in the northern hemisphere. Left, it will be deflects left side in the southern hemisphere. Why? Means due to the rotation of the earth. This was termed after his Coriolis forces. So this Coriolis force is not a actual force. Always remember, Coriolis force is not a actual force. This Coriolis forces is created by the rotation of the earth. So in this slide, you have to remember that the high pressure will be there in the account of 30 to 35 degree northern hemisphere and southern hemisphere. The low pressure will be recorded around 60 to 75 degree north and southern hemisphere. When we are talking about coriolysis, this air will be deflected towards the right direction in the northern hemisphere. Air is deflected left side in the southern hemisphere. This is occurred due to the coriolysis forces, and coriolysis force is not a actual force. Why means it is because of the created by the rotation of the earth. Because of the rotation of the earth, this coriolysis force is occurring. So thanks to everyone.